All right, you ready for the main event? The main event of our chemical reactions is going over the types of reactions. And you might remember from the beginning of the slides, there's a picture about relationships. That's because we're going to go over our 5 different types of reactions, and my analogy that I like to teach and help students remember them is by looking at the types as relationships. So first we have a combination reaction, which sometimes is called synthesis if you want to be extra fancy, a decomposition reaction, a single replacement, a double replacement, and a combustion reaction. So what kind of relationships are we going to be talking about? We're going to talk about combination in terms of marriages, decomposition in terms of divorce, single replacement as the affair, and you'll see about who cheats on whom, double replacement, wife swap, and combustion would be an argument. And all relationships are going to have an argument in them, no matter how loving they are. Okay, so first things first, let's go over our synthesis reactions. So these are when you have 2 or more substances react to form a single substance. So the reactants are normally going to be 2 elements, but there's a couple of places here where you actually see some special reactions, and I'll show those to you later on. So in general, we have this. A plus B yields AB. And this is our typical marriage. 2 become 1. Love is love. I don't care how you um, orient yourself. I just want you to be happy. So we're going to put our 2 things together, and we are going to have our marriage between them. Okay, so how do we marry our elements? All right, well, if our element is going to be some sort of metal and oxygen, it's going to form an oxide. Okay, so if it makes an ion, we need to know those ions. Shocking. Like, I almost said that they would be used all the time. So if we have aluminum and we have oxygen, we know aluminum makes a 3 plus and oxygen makes a 2 minus, and I crisscross them to make Al2O3, and then I'm going to balance everything out. So you're going to make them, and then you are going to balance them. Okay, if it's going to be a non-metal compound, you're just going to basically smush them together unless otherwise told. So S plus O2 makes SO2, P plus O2 makes PO2. If it said P was going to act like a 3 plus charge and you were going to put oxygen together, you would do P3 plus and O2 minus and crisscross to make P2O3 and then balance accordingly. All right. If you are going to have a typical metal and nonmetal, just make your ionic compound. You know your ions. I told you they were important, and I would listen to me. So we have Mg2 plus and N3 minus. So I crisscross, I get Mg3, N2, and then I'm going to balance everything out. All right, so when is it not going to be 2 elements coming together? That is going to be when you have water and either a non-metal oxide or water and a metal oxide. So if you see something plus H2O, this is how you actually make acids. So this is when we get our acids from the supply store. This is what happens. They take SO3 gas and they bubble it through water and they make H2SO4. So remember, acids are going to start with hydrogen. It's going to tell you how many you have. And then you have your nonmetal, and then how many total oxygens do you have in your equation? SO3 plus another O is SO4, and this is your sulfuric acid. If it's SO2 gas with H2O, this is where you make sulfurous acid. Okay, those ions ain't going away. And then if you have your nonmetal oxide and water, that's going to make a base. Now, one of the things that you probably don't know right now is that your acids have H starting off with everything, your H2, and then let's say SO4, your bases are going to have your OHs. So if your acids have H plus and your bases have OH minus, they come together to make water, your H2O. So if you have your calcium oxide and water, you're going to make calcium hydroxide. Remember, calcium is a 2 plus, hydroxide is a 1 minus, so it's CaOH taken twice. Lithium oxide and water is going to be Li plus and OH minus, and you're going to make LiOH and balance accordingly. So if you want to think of like heavy metal, having big bases, metal, all right, that's how I like to think of it, as music and, bases and all that stuff. All right, so if you are to see, or when you do see two things on the left hand together, and it's usually going to be two elements, or you have your special reactions where you have a compound and a water molecule, figure out what your charges are of each one. Okay, use your oxidation numbers if you are using those, or you review them from the ion sheet. Make a neutral product and balance. Okay, don't forget that the diatomic elements are there. Don't let them throw you off. And remember, your acids are made from nonmetals and bases are made from metal. Okay, so let's practice some of these together. All right, we have Al plus F2. So what am I going to do? Al is a 3 plus. F makes a 1 minus. Notice it's not F2. And then I'm going to crisscross these to make AlF3. And then I'll go through and balance them out. Okay, I have 2 here and 3 here, so I can put a 2, I can put a 3, and I can put a 2. Or yes, you could do the Al plus 1.5 F2 makes AlF3. Either of those works. All right, next we have our Mg plus S8. Okay, Mg makes a 2 plus. Sometimes sulfur makes these clusters of 8, but sulfide is still S2 minus, so I make MgS. And then I go through and I balance it out. I would need 8 of these and 8 of these to cancel each other out. So what do I do if I have word equations? Same thing as before, silly. Okay, iron and sulfur. So iron here and sulfur make what? Well, I'm going to have Fe, it tells me I am a 3 plus. Sulfide, it makes an S2 minus. Crisscross those, and I make Fe2S3. And then I balance everything out, and I put a 2 in front of the Fe and a 3 in front of the S, and then I am nice and even. Now what if I have potassium oxide and water? Okay, potassium is a K plus, oxide is an O2 minus, so that means this is K2O plus H2O. All right, is potassium a metal or a nonmetal? Potassium's a metal, so I am going to make a base, and bases end with hydroxide. So what am I going to use? Okay, I'm going to use K plus and the OH minus, and I'm going to make KOH. K. I don't know why that's not working right now. It doesn't like the color green right there. I don't know why. It's so weird. All right, but am I balanced out here? No, I'm going to have to even everything out. I have 2 Ks on the left, so I put 2 Ks on the right. And then I have 2 O's, and then I am all nice and even. Okay, what about carbon dioxide and water? Carbon dioxide, that's a nonmetal compound. So nonmetals make acids. So do you remember how to make the acids? You take your H's, then you take your nonmetal, and then you take your total number of oxygens. H2CO3, that is your carbonic acid. And that all balances out as well. So in case you can't read my chicken scratch, here are the answers for you. Check your work. Okay. And the big thing to do is review, review, review. Practice, practice, practice.